This is The Vintage Space. If you're new here, welcome. If you're a regular viewer, welcome back. Today we're going to be looking at a blast from the past in a couple of ways. It's a vintage lunar mission proposal and something that I covered many years ago. But you know what? I was never happy with that video, so it was definitely time for an update. So let's go! Alternate way of getting to the moon. Let's start with the moon part of this equation. When we think about the decision to send humans to the moon, we typically think about President Kennedy promising the country a lunar landing in 1961, a promise that was NASA's to fulfill. This was arguably the moment when space became firmly a battleground of the Cold War, though it was never really separate from this political conflict. I actually have a whole video about Kennedy's pledge and the subsequent culture of Kennedy moments it created right up here. But interest in the moon predates Kennedy's pledge, which should surprise absolutely no one. Astronomers had been studying it from afar for centuries, using increasingly sophisticated telescopes to reveal surface features to try to understand this nearest celestial body. It remained an object of scientific curiosity in the early decades of the 20th century, inspiring science fiction stories and real science theories alike. And in both cases, people started imagining what it might be like to travel there. Jules Verne's De la Terre à la Lune and Fritz Lang's Frau im Mond brought two versions to the silent silver screen, bringing the idea of a journey to the moon to the wider public. These films coincided with the advent of rocketry, though it was largely a hobby for the major players at the time. In fact, Fritz Lang was so keen to make his on-screen rocket launch look real that he hired Hermann Oberth, the German grandfather of modern rocketry, onto his technical team. He even tried to commemorate the film's 1929 opening with a real rocket launch. So we have hobby rocketry literally taking flight at the same time the public is seeing journeys to the moon on screen. These two things combine to increase public interest in the potential of real lunar exploration, which in turn created the right environment for scientists to be taken seriously and secure funding for their work. Then the Second World War kicked things into high gear. My first book, Breaking the Chains of Gravity, goes into this in depth, particularly with Wernher von Braun and the German team behind the V2. I won't cover it all now because it is a huge story, but there is a link to the book in the description. The vanishingly short version: major players involved in the United States, the Soviet Union, and in particular in Germany, developed missiles as part of their wartime arsenals. And though these rockets were developed as weapons, the engineers behind them did have plans to use this technology to explore space, beginning with the journey to the moon. Fast forward a few years to the mid-1950s. The war is over, and a good chunk of the German V2 team are now American immigrants working with the U.S. Army developing larger, intermediate-range ballistic missiles like the Redstone that have the potential to launch satellites into orbit. Also, the U.S. Air Force is now a standalone service branch developing its own intercontinental ballistic missile like the Atlas that can lift heavier payloads off the planet, potentially even launching a satellite with a pilot on board. The U.S. Navy is also developing and using missiles for both research and defense, namely the Vanguard rocket. Elsewhere in its massive organization, the U.S. Air Force is starting to look at the human factors side of things. The X-15 program, for one, was doing early research into how a pilot could control a vehicle in a near vacuum, while also testing materials that could withstand re-entry through the atmosphere. Another one of its programs was Dinosaur, a sort of one-man shuttle designed to launch vertically on a Titan III, orbit like a spacecraft, and land like an unpowered airplane. In both cases, these programs represented cooperative efforts between the U.S. Air Force and the National Advisory Committee for Aeronautics, the leading aeronautical research group in the country. But there was another thing happening at the time: the International Geophysical Year. This was a period of 18 months in which international scientists agreed to a cooperative study of solar phenomena and their impact on the Earth's atmosphere and environment. As part of the IGY, the US and the Soviet Union were building satellites. Until October 3rd, 1957, the nation's scientists were focusing on these early research programs, and the human space travel goal was fairly far off. Then the Soviet Union launched Sputnik on October 4th of 1957 and totally changed the game. America, by and large, was astounded it had been beaten into orbit, the real shock being the size and power of the launch vehicle. If the R-7 missile could launch a 184-pound payload into orbit, it could launch something heavier across the ocean and hit mainland America. But implications of missile power aside, Sputnik had the effect of making satellites and space exploration a pressing need in the United States. When the Soviet Union followed up a month later with Sputnik 2, things got even more intense. This satellite had a dog on board, Laika, and her rudimentary life support system meant the Soviets were planning a human launch before too long. In early 1958, in response to this rapidly developing space age, the U.S. Air Force's Air Research Development Command initiated a series of industry Air Force studies to examine the military potential of space, including a potential trip to the moon. The resulting program was an audacious four-stage program to land men on the moon by 1965 called Man in Space Soonest. But the Air Force had only assumed it would control America's expansion into space. While the Air Force was planning its space programs, President Eisenhower took a definitive step against a military presence in space. In July of 1958, he signed the National Aeronautics and Space Act that created NASA, a new civilian agency that opened for business on October 1st of that year. NASA pulled together all of the half-formed pre-space programs throughout the country, military and civilian alike, and absorbed the NACA. Again, this is all in breaking the chains of gravity, so I won't cover it here. What we need to know is that NASA passed over absorbing the Air Force's program in favor of the Mercury program we're all familiar with. NASA's Mercury program was a simple, single-pilot orbital program that saw the first American in space. But not before the Soviets scored another first. On April 12, 1961, it launched Yuri Gagarin into orbit. Not launching America's first astronaut didn't deter the Air Force from participating in space, or rather, trying to. When Kennedy sought to reestablish the terms of the space race in May of 1961 by making the moon the finish line, the Air Force presented its full plan to achieve that goal by 1967 for just $7.5 billion, which is almost $65 billion adjusted for today. That proposal was called LUNEX. LUNEX, short for Lunar Exploration, was presented as a preemptive strike against the Soviet Union. After launching the first satellite, the first biological payload, and then the first man into space, Air Force intelligence felt sure the Soviets were planning to go to the moon before long, possibly even with a lab for long-term stays or rovers to cover more distance. LUNEX would beat them to it, doubling as a program to increase America's military involvement in space, just in case this became necessary down the line. To achieve this audacious, multifaceted mission, the Air Force developed a sizable spacecraft. The full payload consisted of a lunar landing stage, a lunar launching stage, and a manned return vehicle that would support the crew from launch to landing back on Earth. The mission was divided into 6 stages: Earth ascent, Earth-Moon transit, lunar descent, lunar ascent, Moon-Earth transit, and Earth reentry. Each stage had its own intricacies and, importantly, abort procedures to bring redundancy and reliability into the mission. The Air Force was looking primarily at a direct shot method. The rationale was that a direct shot would be simpler and therefore faster to implement than an alternative, namely the idea of building the lunar spacecraft in Earth orbit before sending it to the moon. So the spacecraft would begin its mission on top of a 3-stage booster big enough to launch it directly to the moon. It wouldn't stop in Earth orbit. During lunar transit, any small corrections could be made to keep it flying on target. Once at the moon, the landing vehicle could touch down one of 2 ways. It could land upright or at an angle. In either case, it would use a horizon scanner and a Doppler altimeter to make the soft landing on the moon's surface, aided by beacons that would be pre-landed near the designated site. After a short stay on the surface, the lunar launch stage would ignite, sending the manned LUNEX reentry vehicle on a path back to Earth, again seemingly skipping a pause in orbit. Mid-course guidance to correct minor trajectory deviations would help it on the transfer home, making sure re-entry to the atmosphere was optimal. The final stage, atmospheric re-entry and landing, would use aerodynamic braking as the main means of deceleration towards landing. In the final stage, the manned return vehicle would land like an unpowered aircraft at a base. An alternate version saw the same mission launching with cargo only, and in this case it wouldn't return. Cargo missions were designed to send hardware to the moon ahead of a manned mission, or else resupply a crew already on the moon. This direct 6-stage mission was considered the simplest, easiest path to the moon, but the report acknowledged that there were a number of facets that needed to be figured out, or even invented, before it could launch. First, the core spacecraft capable of re-entry into the atmosphere at speeds up to 17,000 feet per second, then landing like a conventional aircraft. That meant sophisticated control and guidance to make the transition from space to air to land in one fell swoop. Literally. And it would need to be made of some material that could withstand all those environments and the challenges they brought. The EXIF team was doing some of this early research, and Dinosaur was contributing research to the style of spacecraft, but there were still a lot of unknowns. Second, the actual lunar landing. Early proposals demanded this stage be capable of slowing the 134,000-pound vehicle from 9,000 feet per second reaching the moon to just 20 feet per second for the actual landing. That deceleration engine needed to be developed, as did the Doppler altimeter and horizon scanners that would guide it to the right landing spot. Third, the lunar launch stage to get the aforementioned lunar reentry vehicle off the moon and back to Earth. Deep space guidance fell under this bullet point too. And finally, the three-stage booster called the Space Launching System to get the whole stack off the ground in the first place. In this early proposal, the first stage was slated to burn either a liquid oxygen-liquid hydrogen combination, creating 6 million pounds of thrust, or a solid fuel option with the same power. Research had to be done to figure out which would be best suited to the mission. The second and third stages would use the liquid oxygen-liquid hydrogen combination, as it's simpler to use in space. This was really the biggest piece of the puzzle. The Air Force identified the launch vehicle as the pacing item that would keep the rest of LUNAC's developments on track. And there was one other big thing too. No one knew much about the lunar environment, so while developing all this architecture, the Air Force would also have to do some preliminary exploration to figure out what pilots would be dealing with in trying to land on this foreign little world. At the time, no one was certain that the moon's surface was even solid. There were theories that it was just dust all the way down, so anything trying to land on it would just flump into bottomless dust. So basically, everything about the mission was unknown and seemed doable on paper only. Nevertheless, the Air Force didn't think any of the challenges were insurmountable and planned in 1961 for the initial LUNAX landings to be the first in a multi-stage exploration of the moon, culminating in a permanent settlement on the lunar surface. Looking at all the unknowns, it might seem like LUNAX was impossible within the Air Force's stated time frame in 1961, but it actually wasn't far from NASA's own Apollo program at the time. Apollo was a similarly half-formed lunar program that existed mostly on paper, a program marked by unknowns and unavailable technologies that was also hoping to land a man on the moon by 1967. Seeking the simplest method, NASA was also favoring a direct descent mission mode with the massive NOVA rocket, with Earth orbit rendezvous as a backup method should NOVA prove impossible to develop. The rocket was, again, considered the pacing item for this program. So with both programs on more or less equal footing in 1961, what might have happened if the Air Force had flown to the moon before NASA? It's possible the current landscape of spaceflight would be very different. For one, the 1960s would have ended with working technology closer to the shuttle than the Apollo capsule-inspired spacecraft, and that might have fed more readily into subsequent programs, either Earth orbital or deep space. Even if a shuttle-type vehicle can't land on another planet like Mars, it could, in theory, support that mission with a crew, launching a dedicated lander from a payload bay. It could have brought reusability and efficiency to the space program sooner as well. On the flip side, LUNAX being a military mission would have left the country with a stronger military presence in space. While this probably wouldn't have changed the inspirational aspect of seeing humans on the moon, it would likely have had a very different effect on the denouement of the Cold War. Apollo was an aspect of this conflict. For sure, let's never pretend it wasn't politically motivated, but it was still a civilian agency undertaking a civilian mission. That America's space program is civilian allowed certain treaties to be put in place, controlling and limiting the presence of weapons in space to prevent it becoming a battleground, which is what Eisenhower had been hoping to avoid all along. A military mission might have opened space to a true conflict. But NASA's existence basically meant we'd never see LUNAX. The whole point of the civilian agency was to prevent the military from gaining a foothold in space. Still, it's interesting to think about what might have been. Alright, so like I said guys, if you're interested to learn more about the pre-space age, my first book, Breaking the Chains of Gravity, goes into detail about the roots of NASA from the 1920s to 1958. And of course, my second book, Fighting for Space, which is about Jackie Cochran, Jerry Cobb, and the question of women in space in the 1960s, is available now in hardcover, audiobook as read by me, and ebook. Both those links are in the description below, as well as a link to the old blog post at PopSci from my original Lunex article. That's going to do it for me today. Thank you guys so much for watching, and I'll see you next time.